Copper is a metal which is used a lot by humans in manufacture of different products, one of the main ones being the insides of copper wires. As such, we need to obtain a lot of the copper, and we find this mostly in copper ore. So much like we saw previously with iron, we obtain that via iron ores. We obtain a lot of our copper from copper-rich ores. But it's important to note that these ores are rocks that we have to physically dig up, and then we have to extract the copper from them. These rocks are of course not infinite. There aren't infinite rocks on the earth. There is a finite supply, and so we will eventually run out. So these ores will run out. Therefore, we need to find more efficient ways of obtaining the copper, because a lot of the time it's not very cost effective to obtain copper from a copper ore if there is not too much copper in there or it's not of a high quality. And so if we have a lot of copper in an ore, so a good copper ore is copper rich. So it's a copper rich ore, okay? And if we have a copper ore with barely any copper in it, that's not really what we want. We call that a low grade ore. Okay, so copper rich ore and a low grade ore. For us to be as effective as we can, for us to obtain as much copper as we can, we need to be able to produce copper out of both of these ores. But because the amount of copper inside them differs, we therefore need to use different methods to obtain it. So there are various ways that we can extract, and we'll start off with the copper rich. So copper rich ore. The first method is if we have copper, we can add to it sulfuric acid, which is H2SO4. This will give us a solution of copper sulfate, which is usually CuSO4. Now bear in mind that this copper, it might actually be copper oxide, or it might be copper carbonate or copper sulfide. There are various different forms that we can find it in, but if we react it with sulfuric acid, then we're going to produce copper sulfate plus something else. So actually I'll show you using copper oxide. If it's copper oxide, then two hydrogens here and the oxygen would also give us water. And so from here we can use copper sulfate in a couple of ways to obtain pure copper. One easy example is, if you remember, iron and many other metals as well are more reactive than copper. And so we can set up a displacement reaction. So if we take our copper sulfate solution and we dip in it some iron, normally just an iron nail or something like that would be fine, iron will displace the copper from its compound, and then we will form iron sulfate, and we're left with copper. Because iron has more power in a reaction, if you like, it's more reactive, it has the power to kick copper out of its compound, and so taking its place, and that's why it's called a displacement. Okay, displacement. And the other alternative is to set up an electrolysis. So if you remember from previous videos, we have a positive and negative electrode. I'll just draw it out. So we have a beaker. We'll have our copper sulfate solution here in blue, and we'll have these two electrodes here in grey. And normally we can make both of these electrodes out of carbon, and so you have positive, negative, like this. So let's say that this is the positive electrode, this is the negative electrode. Okay, remember, negative electrode is the cathode, the positive is the anode, and this is our copper sulfate solution. In solution, the copper and the sulfate separate into their ions, so we'll have copper, let's say copper 2+ ions, going towards the negative electrode because opposites attract. Here, the negative electrode, which will have many electrons, will give the copper its electrons. So copper will take 2 electrons and become copper as an atom, so atomic copper. This is how the element looks, and if you have loads and loads and loads of these ions doing that, you then have copper metal. So if I draw that here in red, this here will be a coat of copper metal on the outside of the negative electrode. So the sulfate ions are going to travel to the positive electrode, but for reasons you don't need to know, the sulfate is too stable really. So what is going to be given off is oxygen gas. So we're going to see bubbles here. Let's draw those in white. Bubbles given off, and those bubbles are oxygen gas. Okay, O2, oxygen gas. But so just in case that's bugging you, and where do the sulfate ions go? Well, the sulfate ions are going to stay where they are in the solution, but in a solution you also have water, because this isn't molten copper sulfate, it's dissolved, so you're going to have water in there as well. And it turns out that you're going to get water actually splitting up and giving away its oxygen. Feel free to read up more on this if you like, or send me an email or a comment about it, but it's a bit too advanced for now. Just remember that oxygen gas is produced at the positive electrode. And so that leads us on to the question of how do we get copper from our low-grade ores? So the methods we just mentioned are from copper-rich ores, but low-grade ores are harder to obtain the copper from because there is not that much of it. And it turns out that really these ores are too hard for us to obtain the copper from. It's going to cost us a lot of money for us to obtain a tiny bit of copper. So what we do is we pretty much hire someone else to do the job for us. And that is in the form of either bacteria or plants. And so if we add bacteria to a low-grade copper ore, what happens is a process known as bio-leaching. Bio just means by something living, and leaching, it's like a leech sucking the blood out of a human. What the bacteria are going to do is suck the copper out of the copper ore. And so the bacteria suck the copper out, and then they leave off some copper as waste. And so we get a form of copper compound known as leachate. Okay, now we can use the methods which we used before, because this is way better for us and way easier to use than it was in the ore originally. And so we can extract the copper from the leachate by either using iron in the displacement or electrolysis. So just like before, but we've added this extra step of using the bacteria to get the copper for us. So how about in plants? Well, plants utilise a method known as phytomining, or the overall method is known as phytomining, when plants obtain the copper and then we obtain it from the plants. Now, plants actually need copper themselves in order to grow effectively. Reasons for this will cross over into your biology courses, but the main one is because enzymes require the copper, and they are of course essential for growth. Now, plants can therefore use their roots, and they can suck up, in a way similar to what bacteria do, but obviously they're way bigger organisms. They can suck up the copper from the surrounding environment, and if those plants are found growing on our copper ores, our low-grade ores, then plants will actually suck up that copper for us. So the plants take in the copper, and then what we do is we actually kill the plants. So we burn the plants and turn them into ash. So then we burn the plants and we form ash. And from the ash, we can extract the copper because it's now in a way easier form for us to obtain it from. We can easily get at the copper inside ash because it's powder, whereas in the rock, there are bits of copper here and there, but it's not pure enough. One way is to literally add sulfuric acid. So if we add sulfuric acid to the ash, don't write this as a chemical equation, this is just to show you what's happening. So the ash plus our sulfuric acid, well, the sulfuric acid reacts with the copper in the ash, and we will get copper sulfate. Now I'm hoping this looks very familiar because from copper sulfate we can produce copper by either adding iron, so then I'll do it in a different colour, then we can either add iron or we can carry out electrolysis. So plus iron, Fe, or electrolysis. That's in exactly the same way as we have just seen previously, and so that is the way that we obtain copper. Overall, this allows us to use more of the copper that is found in the rocks, because in history we haven't been able to obtain the copper from low-grade ores because it's not been economically viable, if you like. So the amount of expense it takes to get the copper out, it wasn't worth it because we wouldn't get too much out. But now we delegate that role pretty much to bacteria and plants. It means that we can eventually get that copper as well, which is great because it means that we are making the most of the resources, and it will mean that copper is running out slower than it would have been. Right, so I hope that's helped. Please do leave me a comment below if you have any questions, but I'll see you in the next video.